Welcome to Module 4, Lesson 3, Dividing Mixed Numbers. Right, so we talked previously about how to divide fractions. Now we're going to extend that to finding quotients of fractions and mixed numbers, finding quotients of fractions and whole numbers, and then creating and solving real-world problems involving quotients of fractions and mixed numbers or whole numbers. All right, so first of all, we're going to take a look at that model again. So like we looked at the other day, if you take a look at what you're doing and put it into a picture, it sometimes helps us to figure out why we're getting the answer that we are. So if you look here, you have Antoinette who is making sushi rolls, and she has 2.5 cups of rice, and she wants to use 1 1/4 cups of rice for each sushi roll. How many sushi rolls can she make? That is the question. So first of all, what we're going to do is we're going to take a look at what she has. So if you look at the picture up here, she has 2.5 cups of rice. So here's 1 cup of rice, 2 cups of rice, and then another half. And what we're doing is we're saying, okay, I'm going to take each of those pieces, the 1 cup, the 2 cups, and the half cup, and I'm going to split them all into fourths. So I know that in 1 cup there are 4 fourths, okay, and then in the other cup there are 4 fourths, and in half a cup there should be 2 fourths. So when I look at how many fourths are there in 2.5, I can just count 1, 2, 3, 4, and 1, 5, 6, 7, 8, and 2, 9, 10 in 2.5. So Antoinette would have enough to make 10 sushi rolls. Right? So which mathematical operation could you use to find the number of sushi rolls Antoinette can make, and then explain why? Okay, well, we could use division, and not just because we know this lesson is about division. So we could use division. I know this because I am taking the 2.5 cups and putting them into groups of 1/4, which is dividing. Okay, so I just look at what I'm actually physically doing. So if you were to actually take that 2.5 cups of rice and put it into groups of 1/4, we know that that's division. So mathematically, what she's doing here, and that's the next problem, is what is the expression shown, then this would be 2 and 1/2 divided by 1/4. All right, so that's the division shown by the model. 2.5 divided by 1/4 with a quotient of 10. So suppose Antoinette instead uses 1/8 of a cup of rice for each sushi roll. How would this model change, and then how many could she make? So think about it. Is the amount that she starts with going to change? The 2.5 cups, is that going to change? No. What's changing is how many she puts in each group. So for my answer, oh, and I'm sorry, it's Antoine. I don't know why I kept saying Antoinette. So Antoine, my goodness. Antoine's divisor would change from 1/4 to 1/8. So essentially what would be happening is we would be doubling. So instead of getting 4 out of 1 cup, we would be getting 8. So we would really be doubling the amount that he can make. So the new expression would be, I'm actually going to do it like this, 2 and 1.
Hang in there.
Thank you. 2 and 1/2 divided by 1/8. Okay, and then if I drew a picture, so again, if I went through, I know that each of these would be split in half to make eighths. So there would be 2/8, 4/8, 6/8, 8/8. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 in there, 8 in here. So that'd be 16. and then these 2 would turn into 4, so that would actually turn into 20. So the new expression would be 2.5 divided by 1/8. The new quotient, so the new answer to our division problem would be 20. So Antoine, not Antoinette, would be able to make 20 sushi rolls. Right, so hopefully this is helping give you a visual and understand why when I do these 2 small numbers divided by, or this small number divided by another smaller number, why it gives you a larger number. Just think, what you're doing is you're taking it and you're saying, okay, I'm going to take these 2 larger pieces and I'm going to cut them up into smaller pieces, which means I should be able to get more pieces. All right, so using reciprocals to divide mixed numbers. So again, it's the same process. It's just now we have mixed numbers. So I have Harold. I guess I can't turn that into a girl's name this time. So I have Harold, and I want to know how many servings are in a 17.5 ounce box. Well, I know that 1 serving, so that's important, of Harold's cereal contains 1 2/5 ounces. And then it is important to note that there are 17.5 ounces per box. So what I'm going to do is I'm going to take those 17.5 ounces, and if I put them into groups of 1 2/5 ounces, that will tell me how many servings I would get. So I'm taking 17 1/2, and I'm dividing it into groups of 1 2/5. And I will make these smaller so you can tell that they are fractions. So bear with me, this does take a couple extra seconds here. Okay, now in order to do division correctly, it's just like multiplication. If I were to just do 17 divided by 1, I'm not actually taking this 17 and making groups of fifths, which is actually what I have to do. I have to take this and say, okay, well, I want to put it in groups of pieces that are the size of 1/5. If I don't turn these into improper fractions, that doesn't happen. These stay as halves. Actually, this stays as a whole, and this stays as a whole, and the only actual division that happens is from the fractions. So I have to convert, so I know I have 17 groups of 2, which is 34, and I have 1 extra, so I have 35 pieces that I put into groups of 2, and I'm going to divide that by my 1 group of 5, which is 5, plus 2 extra, which is 7, and those are going into groups of 5. So I'm taking 35 halves and putting it into groups of 7/5. So basically I'm putting it into something that makes more than 1 whole fraction, and that's okay. So I have 35 over 2 divided by 7/5. Now I do the same thing. Now it turns into multiplication of the reciprocal. This is the most commonly forgotten step. Because of the fact that we have to convert it to an improper fraction, a lot of students stop here and forget that we actually have to flip this. So we flip the divisor, so the divisor becomes 5/7. Because dividing by 7/5 is the same thing as multiplying by 5/7. Okay, and then now I'm actually going to cross simplify here because it makes multiplying easier. I don't want to do 35. I don't want to do 35 times 5. So what I'm going to do is I'm going to cross simplify and do 7 divided by 7, and that gives me 1, and 35 divided by 7 gives me 5. So 5 times 5 gives me 25, and 2 times 1 gives me 2. So now here I have 25 over 2, but that doesn't tell me how many servings. I now have to convert this to a mixed number. Okay, so here I have 25 pieces, and I'm putting them into groups of 2. So I have 2 goes into 2 once, minus 2 leaves me with 0. 2 goes into 5 twice, minus 4, it leaves me with 1 left over. So I can make 12 1/2 servings. Actually, Harold can make 12 1/2 servings with his box of cereal. Again, make it into a mixed number, so your steps again, write the statement. So write the division problem. 2 mixed. I could write mixed to big head, but we want to put mixed to improper. Multiply by the reciprocal. And then solve. Okay, so write the problem so you make sure you flip the right number. Turn all mixed numbers into improper fractions. Change it to multiplication of the reciprocal, and then solve. Okay, so how can I go through this and check my answer? Okay, well, to check my answer, since multiplication is the inverse of division, I can multiply 12.5 by 1 2/5. So I can take my answer, so I'm going to actually write this out here. So I said that 17 1/2 divided by 1 2/5 gave me 12 1/2. So let's turn this into a multiplication problem. I should be able to then take my answer and say, okay, well, if I have 12.5 servings and I multiply that by 1 2/5 of an ounce making a serving, I should get 17 1/2. And when you sit down and work out the math, that works out. So you can double check your answer by using the inverse operation, but you have to remember it's like your fact family. So it's like saying, okay, well, I know that if 12 divided by 3 is 4, then when I double check that, I should find that 4 times 3 should give me 12. So now what if Harold serves himself 1.5 ounce servings instead of 1 2/5? How many servings does that get him? And show your work. I'd like you to try this one on your own, and when you come back, check to see how you did. All right, so he would still have 17 1/2 ounces inside the box, but now that would be divided by 1.5 instead of by 1 2/5. So this would still be 35 over 2, and then divided by, one group of 2 is 2, plus 1 is 3, so divided by 3/2. I change it to multiplication of the reciprocal. Now remember, I take the reciprocal of the divisor. The divisor does the dividing. So if I say 35 halves divided by 3/2, I know whatever comes after divided by, that is my divisor. So in this case, I'm going to change it to multiplication of the reciprocal. And then I can cross simplify. 2 and 2 are both divisible by 2. So I get 2 divided by 2 is 1. 2 divided by 2 is 1. So I get 35 over 3. However, that doesn't tell me how many servings that makes, so I have to take that and make it into a mixed number. So I'm taking 35 pieces and putting them into groups of 3. 3 goes into 3 once. 3 goes into 5 once. And I'm left with 2. So he could make 11 2/3 servings. All right, and I know that my servings should have gotten smaller because my serving size got bigger. All right, so you should have come up with he could make 11 2/3 servings. All right, again, here's the you try. I want you to practice the you try and then come back and check your work. All right, so you do it, come back and check. So you should have come up with an answer of, want to double check here, 8 2/5, which means she would need 9 containers. Okay, if you didn't come up with that, let's go over why. If you did, fast forward and ignore me for right now. So she has 10.5 pounds of potato salad, and she can put them into containers that hold 1 1/4 pounds. So she's taking 10.5 pounds and putting it into groups of 1 1/4. Okay, and I want to know how many containers does she need. And then in this case, it tells us flat out she wants to divide the potato salad into containers. So she's taking that 10.5 and dividing it into groups of 1 and 1/4. Again, we make it improper, so I end up with 21/2 divided by 5/4. Now I change it to multiplication of the reciprocal. I can divide 2 and 4 by 2, and I get 1 and 2. 21 times 2 is 42. 5 times 1 is 5. So in this case, 42, 5 goes into 40 8 times. Minus 40, that leaves me with 2. So that gives me the 8 2/5. But now that means that I still need 2/5 of a container. Well, I can't just all of a sudden make a container that is worth 2/5. So what this tells me is since I'll have a little bit left over, I need to use a 9th container. So 8 2/5 is correct, but that tells me that I would need 9, or Sheila would need 9 containers. Okay, so now we're going to look at a problem that involves area, and with area you have to remember that length times width equals area. All right, so the area is 56 2/3 square feet. The length of the sandbox is 8 1/2 feet. We want to know what is the width. Right, so since as a multiplication problem, this would look like 56 2/3 is equal to 8 1/2 times whatever the width is. So to help us solve that, I know that if I take my area, which is 56 2/3, and divide it by my length, that should give me my width. Okay, so again, I'm going to rewrite them as improper fractions. So in this case, I have to do 56 groups of 3, which is a lot. So I'm going to do it off to the side just to make sure I do it correctly. 6 times 3 is 18, carry the 1. 5 times 3 is 15, plus 1 is 16. So 168 plus 2 is 170 over 3. And then I'm dividing that by 8 times 2 is 16 over 17, or plus 1 is 17 over 2. Now I want to rewrite it as multiplication of the reciprocal, which is awesome because if I look at 170 and 17, I see that they both start with 17. So that tells me that if I multiply 17 by 10, that gives me 170. So both 170 and 17 are divisible by 17. And when I do that, I get 10 and I get 1. So now instead of doing 170 divided by times 2, I can do 10/3 times 2 over 1, which gives me 20 over 3. I like that way better than 170 times 2. Now I have to turn it into a mixed number. So 3 goes into 20 6 times. I use 18 pieces, so I have 2 left over. So I made 6 groups and 2/3 left over. So the width is 6 2/3 feet. Okay. Again, how can you determine if your answer is reasonable? Well, one of the things you can do is you can use multiplication to see, so you can go back and double check and say, okay, does 8 1/2 times 6 2/3 give me 56 2/3? That's how I can check my answer. Or I can use compatible numbers. I can use a form of estimation. So using forms of estimation, I can determine if my answer is reasonable or way off. So here I would use compatible numbers. Compatible numbers are numbers that work well together when you're dividing. They divide and don't give you remainders. So instead of 56 and, what was that, 2/3? Yeah, instead of 56 and 2/3, I could just do 56 and divide it by 8. And I know that my answer, so 56 divided by 8, they're compatible. So this tells me, and this would give me 7. So I know my answer should be near 7. And because of the fact that I rounded down, I know that my answer should be smaller than 7. All right? So you can always use estimation to check your work. And with division, you don't want to round and say like, okay, 55 divided by 5. No, we can look and see that 56 and 8 work together. So I can do 56 divided by 8 and say, okay, if my answer is near 7, I'm good. And in this case, it was. It was 6 and 2/3. It was very close to 7. So I know my answer, even it doesn't tell me if it's exactly correct, but it tells me that it's reasonable. So I could leave it and know that I was reasonably close. All right, and then here you have your 2 your turn problems. I'd again like you to try it on your own and then come back and check your answers. All right, so for the first your turn, you should have gotten 4 1/2 meters. And for the second one, you should have gotten 3 1/4 yards. If you got those, please go ahead and skip to your guided practice. All right, and make sure that if you have questions that you're writing them down and putting them into the guided practice form. If not, and you'd like to go over how we got the your turn answers, that's what I'm going to do right now. All right, so here we have the area is 12 3/8. And so the area is 12 3/8. The width is 2 3/4. And I want to know what's the length. So I'm going to take 12 3/8, and I know that if I take the area and divide it by the width, it gives me the length. So I'm going to divide it by 2 3/4. Excuse me, 12 times 8 is 96, plus 3 is 99 over 8, divided by 2 times 4 is 8, plus 3 is 11. So 11 over 4. I change that to multiplication of the reciprocal. That is an 8 on the bottom. Sorry about that. So times 4 over 11. I know that 99 and 11 are both divisible by 11, so that gives me 1 as my new denominator. And over here, I can do 99 divided by 11, and that gives me 9 as my new denominator. 8 and 4 are both divisible by 4, so this gives me 2 as a new denominator. And 4 divided by 2 gives me 2 as a new numerator. So now my problem is 9/2 times 2 over 1. If you wanted to do 99 times 4, go right ahead, but this is why cross simplification works out really nice, because now I get to do 9 times 2 instead of 99 times 4. Okay, and then here, and I'm sorry, I should have divided this by 4. So this is 4 divided by 4 is 1. So this should actually be 1 over 1. So here I end up with 9 over 2. I have to change that to a mixed number. I have 9 pieces, and I'm putting them into groups of 2. 2 goes into 9 4 times. Minus 8 leaves me with 1 piece. So that gave me 4 1/2, which was correct for this one. Here I have 14 1/2 or 1/12 as the area, and I'm dividing it by the length of 4 1/3. Okay, 14 times 12. It's not really fun to do, but we're just going to go ahead and power through it here. 4 times 2 is 8. 10 times 2 is 20, so that gives me 28. Okay, so the reason that I have to put a 0 here is because this is 4 times 10, which is actually 40. So that here, 4 times 10 gives me 40. And we can talk a little bit more about this so we make sure we get correct answers. And then here, this is 10 times 10, so my answer is actually 100. All right, so here we have 8, 6, and 1. So I have 168 plus 1 extra piece, so 167 over 12, divided by 4 times 3 is 12, plus 1 is 13, over 3. I multiply by the reciprocal. And then we can actually check to see, well, is 167 divisible by 13? Well, 13 goes into 16 once. And this gives me 37. Can 13 go into 37? And no, it can't, so that doesn't work. Since I don't know if this is going to be, well, it's 1 and 13, so since 167 isn't divisible by 13, these two numbers, the greatest common factor is 1. So I can't simplify 167, but I can simplify the 3 by dividing it by 3 and getting 1, and simplify the 12 by dividing by 3 and getting 4. So now I have 167 over 4 times 1 over 13, which isn't so bad because now this is just 167 times 1, which is 167, and 4 times 13, which is 52. And then now I have to do my division to turn it into a mixed number. 167 divided by 52. 52 goes into 167 3 times. 3 times 2 is 6. Okay, and then 3 times 5 is 15. And I'm left with 11 out of 52. And I can see that I made a mistake here somewhere because I should not be ending up with 3 and 11 50 seconds. So 4 times 2 is 8, 2 times 1 is 2, 4 times 1 is 4, 1 times 1 is 1, 8, 6, 1. Ha! Well, here's the question. If this is 168, how did I go to 167? So, my goodness, when I go back and I look at that and realize that I made that mistake, that is just embarrassing. My goodness. Now I have to erase all this. That just stinks so much. But hey, guess what? We all make mistakes, including your math teacher, and that's okay. As long as we go back and check and say, that doesn't make sense. Okay, and a way that I could have checked to see if that made sense without knowing the answer ahead of time is, again, have done 14 divided by 4, or going back and saying, okay, well, 16 is divisible by 4, and checking the reasonableness of my answer. All right, so here, this should have been 169 over 12 divided by 13 over 3. Then this is 169 over 12 times 3 over 13. Now I can check again, see if 169 is divisible by 13. It goes in once. And I get 39, which goes in there 3 times. So woohoo, they are compatible. So I would do 169 divided by 13, which gives me 13. So 13 is my new numerator. I would divide 13 by 13, which gives me 1, which would be my new denominator. 12, I would divide it by 3, which gives me 4 as my new denominator. 3 divided by 3 gives me 1 as my new numerator. So I have 13 over 4 times 1 over 1, which is 13/4, because it's basically saying this times 1. And then I have to change that to a mixed number. So I have 13 pieces, and I'm putting it into groups of 4. Okay, and I know that it can go in there 3 times, minus 12. I'm left with 1 piece, which is 3 1/4. So I apologize that part at the end took a little bit longer, but I wanted to make sure that we got the correct answer here. So if you were doing it and you looked at it and said, but Katie, that should have been 169, good catch. All right, so now go ahead and do your guided practice. And as always, if you have any questions, please be sure to email me or write them down so we can go over them in class.